Right. Today we are learning about the types of motion. Types of motion. In our curriculum, actually speaking, there are three types of motion we can see. The first type is moving with constant velocity. Moving with constant velocity. For this situation, we can simply apply S equals to UT formula. Then you can write U equals to S over T formula. That's a fact we need to understand with that. Okay. Then the second of it. The second one is moving with the constant acceleration. Moving with constant acceleration. Just give me 1 minute. Yeah, right. Moving with constant acceleration. Move with constant acceleration. Yeah. The second one is moving with varying acceleration. Moving with varying acceleration. So in our M1 we are learning with the situations with moving with constant acceleration. If you want to come up with moving with varying acceleration, you have to learn, you have to go up to M3. In M3 only you learn about moving with varying acceleration. We won't go up to that much of advancements in our M1, right? Okay. Then we will continue with that topic. Object moving with constant acceleration. A short form of writing the acceleration like this way, right? Okay. Okay. So in this case, what is a condition to satisfy for an object to move with a constant acceleration? So, okay, say if an object travels with constant acceleration, because acceleration, resultant force is not zero. Resultant force is not zero. That's the first condition. It's not zero, just like if it is zero, it's moving with a constant velocity. But constant is stationary, but we know the Newton's first law. From the Newton's second law, you know that object moves with the constant acceleration. The resultant force is not zero, but it is a constant value. It is a constant value. What do you mean by that? For example, just like this. Look at this object over here. Here the force is 10 newtons, and here the force is 60 newtons. So what is the resultant force? Delta F. Delta F is towards this side, 50 newtons. That is the resultant force over here. Right? That is the first example. So example 1, this is fine. This is moving with the constant acceleration. It's moving with the constant acceleration, right? Okay. Then the second situation, put it just like this. Now, this box, at the initial, at A, the force is 60 Newton and this one is 10 Newtons. When you come up to this point, now B, this force becomes 50 Newtons and this force becomes 5 Newtons. When you come up to this point, C, now you can see this force becomes 45 Newtons and this force becomes 1 Newtons. Then at A, what is the resultant force? Resultant force is this side, 50 Newtons. It's unbalanced. At B, what is the resultant force? This side, 45 Newtons. When you come up to C, resultant force is this side, 44 Newtons. Now what you can see, now the resultant force is not zero. That is correct. First condition satisfies. First condition satisfies. But here what you can see, now the resultant force varies. So I'll get this mass as 10 kilograms. Then what is the acceleration over here? Acceleration is 50 divided by 10. It's 5 meters per square second. I'll get this one as 10 kg. 10 kg. Over here, what you can say, Pute? You can say here the acceleration is how much, Pute? 50 divided by 10, that is 5 meters per square second. Here the acceleration is 45 divided by 10, that is turn up to 4.5 meters per square second. Here, what you can say, Pute? It's 44 divided by 10, it's turned up to 4.4 meters per square second. So what you can understand, Pute? So the acceleration varies with time. Acceleration varies with time. Therefore, this is not what? This is not a
Constant.
constant acceleration. So you can say it's not moving with constant acceleration. Not moving with constant acceleration. Then, so this is a situation, right? Then if the object, if any object moves with constant acceleration, we can use these equations of motion. If any object moves with constant acceleration, we can use below equations of motion. But remember, you cannot use these ones if the object is moving with a varying acceleration. That one you have to keep in your brain thoroughly. These formulas are only valid if the object is moving with a constant acceleration. Right. The first formula is V equals to U plus AT. Next one is SC equals to UT plus half AT squared. Other one is V squared D equals to U squared plus 2AS. Other one is SC equals to U plus V over 2 into T. These are the formulas. I think you are aware of these terms. What is descriptive terms? What is V? What is U? What is A? What is S? And what is T? Is there anyone who is still not aware of these terms? You have already learned this in your IGCSE physics as well as in AS physics also. I think at the moment you have already learned. Is there anybody still who don't know these terms? Descriptions for these terms? Aflal, Shrutivarnan, Venuvi, Adril?
So we all learned in A-level physics, sir.
Yeah, that's fine. Right? Okay.
Equations of motion, sir.
Yes, equations of motion, right? These ones. So you know the descriptions, Pute. Then in this case, Pute, this one. If the acceleration is 0, if the acceleration is 0, that means what you can say, it is moving with constant velocity. Moving with constant velocity. What happened to these equations? The first
We
one,
can
yeah, acceleration is 0, Pute. Here the A is equal to 0. Then what happened to the first equation, Pute? V equals to U plus 0 T. Then what happened, Pute? V is equals to U, obvious, no? Because you know that final speed and the initial speed, both speeds are similar. Is that clear, the first condition? Right. Second one, SC equals to UT plus half into 0 into T squared. Then what happened, Pute? SC equals to UT. Distance equals to velocity into time. Displacement equals to velocity to time. So it's obvious, right? So you can use this. The next one, V squared D equals to U squared plus 2 into 0 into S. Then V squared D equals to U squared. Again, it comes to this equation. V equals to U. Right? S is equals to U plus V over 2 into T. Therefore, we know that U equals to V. Therefore, you can say S equals to U plus U divided by 2 into T. That is again S equals to UT. Again, it comes to which equation? This equation, rho. So these equations are valid for usual equations as well, what you learned in our moving under constant velocity, even the same conditions, but with the zero acceleration. But remember that none of these formulas are applicable for the situations with what? With varying acceleration. If the acceleration is varying, you can use none of these equations to explain the movements, but instantaneous points can be explained. Later on, you'll understand that what do you mean by instantaneous points. Other than that, you can't use it. Those are the main facts we should know about these equations of motion. Right? Okay.
Sir,
Yes.
that last equation s equal u plus v over 2 times t, that one, how did you get x equals ut?
Yeah, look at this, Pate. U is equal to v, no? U become v, therefore u plus u. U plus u is 2u. 2u divided by 2 is how much?
Ah, okay, sir. Okay.
Ut, no? Same thing as this. Right? Okay. Now, right. From examples, we need to understand how do we supposed to get these values. Right. Now, how to understand which application, which equation.
Should we copy anything, those things?
I will send you this note. Okay?
Okay, sir.
Right, that's the matter. Right. Yeah, we'll go with this.
No, I tried to do the first questions of the book. Yes, I read the first chapter in the mechanics.
Right, we'll come up to this one. Because the applicable part is from here, equations of motion. Because these things are the basic ones. We'll come up at the explaining with this. The rest
Starting
of the
part, like I didn't understand.
But yeah, just keep the first chapter. This first chapter is joining with the other fact of these equations. We'll do the equations of, sorry, graphical motions a little bit of later, because initially we have to get some idea on that, how to do these, what do you call that, motion graphs. That has to be done a little bit of later. For the moment, we'll start with the equations of motion. After going a little bit of it only, we'll be come up with the what do you call motions with graphs. Right? Okay. Right. Now let's come up to this one. Okay. Here, we have already done these questions before, so I'll just erase this. Then we will try to, I will try to explain these ones. Other than that. Give me 1 minute. Right. Because for the initially we need to learn a little bit of about this motion graphs or motion equations. After that, we can come up with the equations of motion. Okay, right. Okay, let's start from here. Right. Okay, start from here. This is page number. The first question we are explaining is from here. Yeah, sorry. 1 second. Yeah, from here. But I'm going to explain from here. Right. I'll just. Right. Now let's see how. 1 second. Yeah, okay. So I just made a mistake anyway. Let's see if I can just. No, we have to do it. I can't help. Then, but this is just like this. I'll just. This was the. I was explaining this one for the previous classes. Even for your previous batches, the same book I'm using. Right. Anyone is having this textbook with you? Right. Okay. Okay. A cyclist is traveling along a straight.
Only the soft copy, sir.
Yes. The accelerates at a constant rate from a velocity of 40 meters per second to a velocity of, as I remember, this is 7.5, yeah. 7.5 meters per second in 40 seconds. In 40 seconds. Fine. The distance traveled in 40 seconds. Now let's see how to answer the question and how to make sure which formula to be used. Right. Initially, it's starting from a constant rate of velocity of this. This is the starting point. Therefore, we know that u equals to 4. We know that u equals to 4. To a velocity of 7.5. This is the ending up. Therefore, v equals to 7.5. In 40 seconds, time is 40. We need to find the distance traveled, right? Then we have u. We have u. We have v. And we know what is t. We need to find what is s. Now see whether what is the relationship joining u, v, s, and t. We have to see whether what is the equation adjoining u, v, s, and t. Simple formula is how much? What is it?
S equals v square plus u square over t.
With that, you can get this answer. We cannot use s equals to ut plus half a t squared. Why? Because we don't know what
Acceleration,
is.
we don't know.
We can't apply v squared equals to u squared plus 2as. Again, acceleration we don't know. We can't apply v equals to u plus at because acceleration again we don't know, and the time also not asked. Sorry, time is good, but acceleration we don't know. Any kind of facts are not understood from the first question. They are worrying about s. Right. If we apply into this one, you can get the answer 230 meters. Right. Now, the next question is her acceleration in 40 seconds per day. Then we need to find acceleration. Then we know v. 7.5 we know.
A equals v minus u over t.
Yes. So, and a is the one we need to find it. T is 40. So simply apply v equals to u plus at, and from here you can get the answer. Remember that you need to replace the units. That is compulsory when you do this kind of question. That's the first thing you need to understand. Right. We'll come up to this question today. Right. A particle moves in a straight line from point A to point B with a constant acceleration of 1.5. I'll just draw a small diagram from A to B with a constant acceleration. Constant deceleration, sorry. Therefore, I can mark A is minus 1.5. Why it's minus? Because it's a deceleration. Because it's a deceleration.
Deceleration.
Yeah. The velocity at A is 8. U is 8. And the velocity of the particle B is 12. So therefore, V is equals to 2. Right. Find the time taken for the particle to move from A to B. Right. Now you know U, V, and A. We need to find the value for T. What is the relationship adjoining U, V, A, and T?
A equals v minus u over t.
A equals to V minus U over 2, or you can write V equals to U plus A. Whatever the format is correct. You also wrote the same equation. V is 2, U is 8, plus A is minus 1.5 into T. Therefore, you can say 1.5 T equals to 6. Therefore, T is equals to 4 seconds. That's the answer where we need to obtain. Then the distance from A to B. Now we know the acceleration as well. Yes, give me 1 minute. Right. Then the next one is then the part B is distance from A to B. Then we know U, V, A, and S. So we can apply V squared equals to U squared plus 2AS. Because we know V, U, A, we need to find S. So it's turned up to 2 squared is equals to 8 squared plus 2 times of minus 1.5S. So it's turned up to 464 minus 3S. Therefore, 3S is equals to 60. Therefore, S become 20 meters per day. That's the answer for that. Okay, right. Then, after anything? After reaching B, the particle continues to move along a straight road with a constant deceleration of 1.5. Still, you are moving with the same condition. The particle at points is T seconds after passing A. right? So here the time is 0, here the time is 6. Find the velocity at particle C. So you know that it's following up the same velocity conditions. Therefore, again, we can apply V equals to U plus 8. We need to find what is the final velocity. U is 8, A is minus 1.5 into time. Time is after 6 seconds, right? Now the condition here, what we need to understand is when you are working out with this, no need of applying a different equation of motion starting from here to here as a one motion. The reason is acceleration. It's having the same amount of deceleration, same amount of acceleration. Therefore, from here onwards, you can use the same equation of motion. Now let's see, it's a pretty interesting fact. It comes minus 9. It's turned up to V is equals to minus 1 meters per second. I'll explain this matter a little bit of later. Then we need to find the distance from A to C. That is pretty interesting. That is the point we need to understand that. It's a minus velocity. Minus velocity means what kind of a motion is this? That's the point we need to understand today. Now at A, it's moving to this side with 8. At B, it's moving this side with 2. At C, it's moving this side with 1. That's the point. That means this object is a motion like this. It goes like this and it turns back. It goes a little bit further and it returns. That is a point we need to understand in this question. Now we need to see whether the question we arise in this fact is the distance. Distance we need to find what is the total length from starting from here, go along this side, this side, this side, and this side. We need to add up all of these facts together. So initially, I try to find out the distance from here to here. I'll just mark it as A to P. P means what is the point? Condition at P. We know that at P, we know that V is equals to 0. Then we can apply. We won't find the distance from A to B. I'll just apply V squared equals to U squared plus 2AS. Right. V squared is 0 at P. U squared is 8 squared plus 2 into minus 1.5 into S. Then S become how much? Turn up to 64 divided by 3 meters. That is the distance from A to P. Now I need to find the total distance. Again, I'll try to find out distance from A to C. Then I'm moving from A to B. I'm worrying about. I'm going to find out the length from A to C. I'm going to do this today. Right. How to find it? At A, what is the velocity? U is 8. At C, it's minus 1. Nothing to worry. A is minus 1.5. We need to find S. Again, I'll apply this side. V squared equals to U squared plus 2AS. Minus 1 squared is equals to U squared is 8 squared plus 2 into A. A is minus 1.5S. Then we get the answer S equals to 64 minus 63 divided by 3. It's turn up to 21 meters. Right. Now let's go ahead with this. Okay, right. 64 over 3 is how much? 64 divided by 3 is 21.33. This is 21.33. Now we need to find the total distance traveled. Right. Then let's do a little bit of a geometry. This is how it comes with it. A to P is 21.33 meters. A to C is A to B. Is this? A to C is 21. Now I need to find the distance traveled. They would need to find the distance. Up to here, what is the length? 21.33. And it has come back this much of a length. What is the length over here?
0.3.
Yeah, plus
0.
another 0.33 should be returned. So the final answer, 21.66 meters or 67 meters should be the total length it travels to. That is the way of understanding this kind of a question. A little bit of a geometry is there. Those are the questions at the end of this topic. So, but it's basically at the top of this one. So that kind of extend the question, even we should know how to do it. That's how it comes. Here the answer is wrong. When making it as a special feature, we need to understand they just gotten as a displacement, not the distance. Okay, that's a fact we need to wake up. Then when you come up to this question today, a car moving from traffic light along the straight road with a constant acceleration. The car start from rest. That means what you can see, car start from rest means u equal
U0.
Initial velocity is 0.
Yeah, that's great. Good. The traffic light and 30 seconds later, time is 30 seconds. The car passes a speed truck where it registered as a traveling at 45 kilometers per hour. Now, we have a doubt because all these facts are given in seconds and meters, but here it's given in kilometers per hour. How to convert kilometers per hour to meters per second?
Multiply by 3600 and divide by 1000.
Yeah. Kilometers per hour should be converted into meters per second. How to convert kilometers into meters? Multiply by 1000. How to convert hours into seconds? Multiply by 60 into 60. Hours into minutes 60, 60. So it should be turned up to multiply by 1000 and divided by 3600. It's turned up to 12.5 meters per second. Right. Now you know that is V. Okay. Find the acceleration A. We can apply V equals to U plus AT. V is 12.5. U is 0. A is the one we need to find it. Time is 30. Therefore, A become 12.5 divided by 30. That is how much is it? Just check me.
0.416.
Yeah, 0.416. Another you can say 5 over 12 meters per square second.
So
The
there's a
distance
7,
between
sir.
the traffic lights. Yes, fill it out.
4167.
So yeah,
0.
4167. That's great. Good 7. Okay. The next fact. Distance between traffic lights. You know that U is 0, V is 12.5, T is how much? T is 30. We find what is S. You can apply C equals UT plus RP discard. That is true. But in any case, if you make a wrong answer, it might be having impact. So rather than that, it's easier to use U plus V over 2 into T. This is the only equation which is not involving the displacement. U is 0. It's 12.5 divided by 2 into time. Time is 30. So with this answer,
187.5.
yeah, 100.
87.5.
Yeah, that's great. So the answer is 187.5 meters per second. That's the answer where we need to work out with this. Over here also, you have this wave transfer.